Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at identity and inverses. So in sets, the additive identity is usually denoted 0, the multiplicative identity is denoted 1. The additive identity is so called because when you add 0 to a number, you don't change the identity of that number. Similarly, if you multiply by the multiplicative identity, if you multiply a number by 1, you don't change the identity of that number. So closely related to identity is the concept of an inverse. So an additive inverse takes a number to 0, the additive identity. A multiplicative inverse takes the number to 1, the multiplicative identity. So the additive inverse of A is usually negative A, and the multiplicative inverse of A we denote as A to the power of negative 1. But we will look at a lot of sets in which there isn't a multiplicative inverse. So to illustrate this point, let's look at the integers modulo 20. So if you look at a number like 3, its inverse is just negative 3. But negative 3 isn't a member of integers modulo 20. But remember, we can just add or subtract multiples of 20 to find an equivalent number. See, negative 3 plus 20 is equal to 17. So negative 3 is equivalent to 17 mod 20. So 3 and 17 are additive inverses of each other. Because if you add them together, you get 0 modulo 20. On the other hand, 3 and 7 are multiplicative inverses of each other, because 3 times 7 is 21, which is equivalent to 1 mod 20. So 3 and 7 are each other's inverses because they take the other number to 1 when multiplied. But not all integers have a multiplicative inverse modulo 20. Let's look at the number 10, for example. So 10, if you multiply it by any number, any integer that is, you get another even integer. So it's impossible for you to multiply 10 by an integer to end up at 1 mod 20. 1 mod 20 has to be odd. The numbers equivalent to 1 mod 20 are 1, 21, 41, 61, 81, and so on. You can never multiply 10 by an integer to get any of those numbers. So 10 is actually a number modulo 20 that does not have a multiplicative inverse. It turns out that if an element modulo n does not have a multiplicative inverse, it is what we call a zero divisor. So 10 is a zero divisor because you can multiply it by a non-zero number to get 0. In fact, 10 times 2 is equivalent to 20, or 0 mod 20. So 10 and 2 happen to be zero divisors. It turns out in the integers modulo n, every number is either a zero divisor like 10 and 2, or what we call a unit like 3 and 7. 3 and 7 are units because they have a multiplicative inverse. So 3 and 7 are units in modulo 20. 10 and 2 are not units in modulo 20. They are zero divisors. It turns out that everything modulo n is either a zero divisor or a unit, but never both. So it's really important for us to understand which numbers will have a multiplicative inverse, because the multiplicative inverse is akin to division. It allows us to undo multiplication. So let's look at this example modulo 20 here. So Bezo's identity says that ax plus 20y equals 1. It will have a solution for x and y both being integers if and only if the highest common factor of these two, of a and 20, is equal to 1. So let's take this equation and reduce it modulo 20. Of course, 20 times an integer is going to be 0 mod 20. If I reduce this equation modulo 20, I'm just left with ax is equivalent to 1 mod 20. So Bezo's identity basically tells us that ax is equivalent to 1 mod 20 will have a solution if and only if A is co-prime to 20. So we could use that logic for modulo any number. The idea here is you can multiply an integer by something to get the multiplicative identity if and only if these two numbers here are co-prime. So what this is saying is that x, a number modulo n, it will have a multiplicative inverse if and only if x and n are co-prime. So the only numbers modulo 20 that would have a multiplicative inverse are precisely the integers that are co-prime to 20. So like 3 and 7 I know are units, they have a multiplicative inverse. 5 on the other hand, I know that will not have a multiplicative inverse because 5 and 20 are not co-prime. They have highest common factor of 5. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.